So today's our last lesson for chapter 3, and honestly, it's probably the weirdest lesson of chapter 3. It's not the most important, but it's the weirdest. And if you don't understand today's lesson, if it's like way too weird for you, honestly, you can totally skip this lesson and get a 5 on the AP exam. Usually, there's one multiple choice question on each AP exam with this topic, and in some years, I've even seen it skipped entirely. But normally, it's just one multiple choice and that's it. If you're really unlucky, you might get 2 multiple choices, but it's very, very uncommon. So it's not a big topic, right? Product rule, power rule, chain rule, quotient rule, those are going to be mixed throughout a ton of questions. But this derivative inverse, it's a very just tiny little topic. So, try to understand it, but if it's too weird, it's something that honestly we'll kind of even forget about as we go throughout, and it'll be something that like in March and April, I'll start to remind you, hey, we need to remember this topic and just memorize it for the exam. So before we do that, let's just kind of talk about Math 1, Math 2, probably Math 3 the most. We had the word inverse. And an inverse was, when you had like y equals x squared plus 3, and you flipped the x and the y, and wrote like x equals y squared plus 3, and you solved for the y. So you got like, y squared equals x minus 3, took the square root, like y equals plus or minus the square root of x minus 3. We called this our inverse equation. So that's an inverse. Now, in calculus, we write our inverse as f negative 1 of x. So f negative 1 of x is our inverse. And kind of the key about this is if f of 3 was equal to 5, well, if you flip the 3 and the 5, the x and the y, then we know that the inverse of 5 would be 3. So the f negative 1 of 5 is 3. That's the big key about an inverse. So numerically, what we say is that f negative 1 is numerically defined to be the function whose domain, those are the x values. So the domain of f1, like the function whose domain, right, like the domain of f negative 1 of x, is the range, is the y values of f of x, of the original, and whose range, so whose y values, is the domain of x, f of x. So it's basically just saying, that's a really fancy way of saying, to just switch the x and the y. That's the really easy way to say it. So our graphical representation of the inverse function, and this is a little bit weird, but it's just going to be that we flip it around the line y equals x, right? It flips around that line. Because what's happening is you're flipping it, the x and the, like basically you're flipping the x's and you're flipping the y's, so it's going to flip around the line y equals x. So it can work for any function. I mean, even if we just had a weird, kind of piecewise business of, -1, -2, -3, -4, -5, 1, 2, 3, 4, 5. So if we had a point at like -5, -5, if we had another point at like say -4, 2, and we even made this into like a piecewise, and we had a point at like -1, 1. Right, so if we called this f of x, right, so we have a point at -5, 5, -4, 2, and -1, 1. So for our inverse, right, I'm going to use another color, we'll use red. What's going to happen is we're just going to flip our x and our y. So if we flipped -5, 5, that would turn into 5, -5. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So 5, -5. That would be on our inverse function. If we flip -4, 2, that's going to turn into 2, -4. We're just switching the x and the y. So 2, -4. So we can graph that. Right, connect those. And then if we flip -1, 1, it's going to be 1, -1. So this would be our f, not f prime, oops, don't write f prime, it's f -1 of x. That's not a prime, it's an inverse. Okay, and analytically, so graphically, basically what we do is graphically negative 1 of x is the reflection of f of x over the line basically y equals x. Now you also could say it's, first you do a horizontal reflection, then you do a vertical reflection. That works too. Okay, and then analytically, right, that's more like with our x's and our y's. Basically what we can say is if f negative 1 of x is the inverse, and this is what we use the most, and this is pretty cool, of f of x, then what happens is, then when we plug them into each other, so f of f negative 1 of x, like if we plug one into the other one, we're going to just get back the answer x. Or we could say kind of like an and or case, f negative 1 of f of x, if we plug f of x in, we get back x. So if we plug either one into the other one, we get back x. And you could even see that up here, right? Like if we used, in the beginning we just said, hey, that's how we would do it back in math 1, right? So if we had like basically f of x, here's like an example. If f of x is x squared plus 3, and we say f negative 1 of x, let's just use the positive case, would be the square root of x minus 3. Well, if we plug in f of f negative 1 of x, that's like saying, hey, let's plug in for x squared, we're going to plug in square root of x minus 3, where we see x squared plus 3. Those cancel. X plus 3 minus 3 would just give us back x. So I was doing this first one, right? That's what we did here. Now the other one would just be plugging in backwards. So we would be taking x squared plus 3 and plugging that into x. If you see, you can do that one in your head. X squared plus 3 minus 3 is the square root of x squared. The square root of x squared gives us back an x. So it works both ways. So that's kind of how we do that. So now, again, this is just still review. This is still just inverses. We haven't even worried about derivatives yet. But, let's just kind of practice these. So if we have x at negative 2, f of x is 3, and g of x is 1, right? Let's complete these table of values. So for x, what would we know about the inverse? Well, we know basically this is, this is saying f of negative 2 equals 3. So we can flip those 2 points. So we know the x value of 3, that the inverse has a negative 2. And similarly, we can flip those 2 points. At an f value of 2, our inverse value is 1. Right? We flip those 2 points. We can do the same thing for g, right? At g of negative 2 is 1. So if we flip those points, we get 1, and then we get negative 2. And same thing, g of 1 would be negative 2. Right, like at x equals 1, the g value is negative 2. So if we flip those 2 points, we get negative 2 and 1. Okay, so that kind of helps us out. Now let's do a little bit of a harder thing, is let's plug in what's f of g negative 1, the inverse of negative 2. Well, the inverse of negative 2 is right here. So this is saying f of positive 1, right? That's the inverse of negative 2. And so f of 1 is up here in our graph, f of 1 is 2. I know it's a little confusing, but that's why we're going to do these, practicing. What would be the inverse value of f of 1? Well, first let's do f of 1. Where's f of 1 on our graph? Again, this is the x value, so f of 1 is 2. So what is the inverse value of 2? Well, the inverse value of 2 is 1. G inverse of g of the inverse of f of 2. So the inverse of f of 2, we just said this was, again, 1. So we're going to put the 1 in there. So what's the inverse of 1 for g? The inverse of 1 of g is negative 2. And this last one, I'll use another color. The inverse for f of g of the inverse of g of 1. So we always start from the inside. So we're always going to start with the inverse. The inside. What's the inverse of g of 1? The inverse of g of 1 is negative 2. So now we're going to leave everything there the same, but then right here we're going to change that to a negative 2. So now what's the g of negative 2? G of negative 2 is 1. So now it's what's the inverse of 1, and the inverse for f of 1. Did we mess that up? Oh, okay, I know. So on this one, basically just based on the table, we don't have this. So I don't know if we necessarily say it's undefined, but if these are the only values that we have, then technically it's undefined for this table. Either undefined or maybe you say not enough info, right? Because we don't have that answer. Okay. So next, kind of given this relationship, basically there's going to be a rule that starts to work. And so because we know that f of f negative 1 of x is equal to x, like we know that that's true, this is the proof. Okay, you don't need to know the proof, but I'm going to show you guys the proof. So we could take the derivative of both sides. So this is chain rule. See how we have f of some box, right? Remember when we did like f of g of x? We said it was like f prime of g of x times g prime of x, right, where this is our box. So we're going to be doing that same process. The outside is f. So if we take the derivative, we're going to get f prime of, now we're going to leave f negative 1 of x alone. Then times, now we're going to do times the derivative of f negative 1 of x. Now we don't know what that is, so I'm going to just call it d dx of f negative 1 of x. It's basically f negative 1 of x prime. Would be equal to just 1. Now, this is what I'm trying to solve for, is I want to know what is the derivative of this guy. So what is the derivative of this guy? So we're going to just divide both sides by f prime of f negative 1 of x. Divide by f prime of f negative 1 of x. And so what that gives us is that the derivative of an inverse function is 1 over f prime, the derivative of f of the original inverse. And this is our formula. And I know that's kind of weird. It's a very weird formula to even understand. It just looks really weird. I warned you guys at the beginning of the day. But essentially what that's saying is, if f and g are inverses, right, if we know that they're inverses, then basically g prime of x would be equal to 1 over f prime of g of x. And this is a much easier way to kind of think of it than all those weird like f prime, f negative 1s. And so basically what it's saying is that you do the derivative of, you take the derivative of like g's inverse, and then into that derivative you plug in g's original. So it's a little bit weird, but we'll practice it. So what we know here is f of x is 3x plus 2. And here's, it's really weird, but I like to make a little table. And when I make this table, it makes it so easy. So here's what I do. I always make a table. I always put in f of, basically we want to know what is f prime of negative 4. Okay, and this table's really going to help us out. So the issue is that a lot of times the questions are just written so weird that you really have to kind of figure out what to use. And so that's why I like kind of doing the table. And so what I end up doing with the table is that we want to know what is the value of f negative 1 of negative 4 prime. So they're kind of saying what is the derivative of f negative 1 at x equals 4. And so that g of x, like basically I always think of g as being my f negative 1. So we always put g right here, and we're going to put basically g of negative 4. So what is g of negative 4? Now, this is going to be f of something is equal to negative 4, right? So the f goes in the first column, the g goes in the second column. I always put f prime of x in this third column. I always put f prime of, now this is going to be whatever is here. And that's going to be the same number here, and that's going to be the same number here. So those three numbers are going to match up, and that's because of the whole flipping thing, right? We know that they flip back and forth. So basically, this is a little bit weird, but we know, and this is the hard part of this, we know that g of -4 is going to be equal to some y value. And we know that f of that same y value is going to equal to -4. And that's the important part, is we know that we can flip it. And so even though this was the x value for the inverse, since it was the x value for the inverse, it means it's the y value for the original. So what we can do is we can say 3x plus 2, this is the hard part, is equal to -4. And so again, what I did is I took the x value for the inverse and I plugged it into the y value of the original. So we can say 3x equals -6, so x equals -2. So now what I know is I know that basically f of -2, if I plug in -2, we're going to get -4. And you could try that again. 3 times -2 is -6, plus 2 is -4. Right, so f of -2 gave me -4. So that means if I flip them, g of -4 is going to give me -2. Okay, now our next step is take the derivative. The derivative of 3x plus 2 is 3. So now our final step is to say, okay, what is f prime of that like y value from our inverse? So f prime of -2, I'm going to plug in -2 into my derivative, and we're going to just get 3 again. And so our formula is 1 over this number. So the derivative with respect to x of f prime, or of f of -4, would be equal to 1/3. Right, and that's because that's just the way the formula works. So that's kind of the table I set up. I know it's really weird. I guess you could do it kind of the way that they have it set up, or the way that the formula is set up would be, if I was doing it in the formula, would be to say 1 over f prime of f -1 of 4. So it's like saying the inverse of 4. Now, how do we get the inverse of 4? We take 4, it's our x value, and we plug it in for the y value of its inverse. So we did that. So it's like saying 1 over f prime of -2, right, of this answer that we got. Now, how do we do that? Well, first we need to take f prime of x, and f prime of x would be 3, and so then we need to do f prime of -2, which is also 3. So f prime of -2 we plug in is 3, 1/3. So I use the table, and I just kind of think, whenever I make this table, so if you want to kind of put this in your notes, I was just going to make a table, and I just say, this is f of some number, then we have g of some number, and we know that these are flipped. So whatever goes here is going to also end up here. Then I put in f prime of x, and then I do f prime of that same number, that we have that same number, that was our y value and our x value. And then whatever I get here, it's going to be 1 over that. So I don't know, it's weird. Okay, these are very weird. Like I said, we're totally going to forget about this after our test. We're going to have to remember product rule, we're going to have to remember chain rule, we're going to have to remember quotient rule, power rule. But the inverse derivatives, we're going to see like once or twice again until our AP exam. So it's just something that you kind of memorize the day before the exam. So anyways, kind of doing this, same thing again, right? What I do is, okay, I'm going to put in f of, now, it's not going to be 3, basically it's going to be f of some answer gives us 3, right? Because this was the x value, now it's going to be the y value for regular f, if that makes sense. Then the f -1 value of 3, so what's our f -1 value of 3? Well, that's like saying what y value was 3. So here's 3 as a y value. So this is going to be 1, and that's going to be 1. Now, f prime of x, if I had a formula, I would write it as a formula. But if it's a table, we don't even have a formula. It's just from the table. So we can skip that line. And now we're going to do f prime of, remember we do f prime of 1. So f prime of 1 is going to be 2. So we're going to get 2 here. So our answer is 1/2. And that's how we do those. I know they're a little bit strange, but that's how I always do it. Okay, you could use it, do the whole formula, do it step by step, but I like to just kind of make this little chart to help me out. So what I do again is I take my y value, so g negative 1. So g of something is going to be negative 2. That's going to turn into the y value, right? It was the x value. It's going to turn into the y value. So what y value, let's use another color like blue. What y value did g become 2 at? It became 2 at negative 2. So we're going to flip these. That means g negative 1 of negative 2. Oops, this was... Ooh, I messed that up. Okay, I messed that up. I did positive 2. So let's start this over. That's my fault. So we wanted what g value gave negative 2. So again, what this is going to say is g of something gives an answer of negative 2. And the negative 2 is actually here. So that was 1 again. So g of 1 gives us negative 2. So that means g negative 1, right, our inverse of negative 2, that gives us the answer of 1. So again, we can skip this line for a table. And so g prime of that 1 is equal to 1. So our answer is 1 over 1, or just 1. Okay, and that's how we do it. The long way would be to just really write it all out. 1 over g prime of the inverse of negative 2. That would be the long way to write it without using my table. So if you don't like the table, just do it this way. G prime of, now the inverse, what this means is, this means what y value gave negative 2. What y value gave negative 2 was 1. And what is g prime of 1? Well, that's this part, 1 over 1. So that's the other way to do it. Okay. So just practicing it, I would highly recommend you guys pause the video right now and just try this on your own. Just try to do it on your own and then see if you can do it. Okay, so this one wants an equation of a tangent line to the graph of the inverse. So the x1, the y1, and the m. Now, we got to be careful because it says first find the value of g negative 1 and then use it to help with the tangent. So we definitely want to be careful, but we know that the x is going to be 1, right? Now, what would be the, it says find the value of g, the derivative, but before we do that, I'm going to just go step by step. So what would be our y1? Okay, so how do we get our y1? Well, what basically is saying is g negative 1 of 1 is equal to essentially the y value when g of something equaled 1. So what g of something equaled 1? So here's g of 1. G of 3 equaled 1, so that means the inverse of 1 is 3. Okay, so that means our y value is 3. Right, and then for the slope, we can either make our table, or you can do it the other way. I like it with the table, so I'm going to put in g of 3 equals 1, and our inverse of 1 equals 3. So that's the value that we do g prime of. So g prime of 3 is negative 2. So this is going to be negative 2. Yeah. Oh, wait, not negative 2. It's 1 over negative 2. Okay, I knew I was missing something. 1 over negative 2, or negative half. So we're going to get y minus 3 equals negative 1/2 times x minus 1. That's going to be our equation. Now again, if you didn't want to do the table, right, instead of doing the table, if this was like, hey, I just don't get that, basically it's 1 over, now we're using g, so it's g prime of the inverse of 1. Well, what's the inverse of 1? We said that's when the y value is equal to 1. The y value is equal to 1 at 3. So what's g prime of 3? That's negative 2, so that's why it's negative 1/2. So either way you do it, great. Estimate the value of g prime of negative 1. Now this has nothing to do with inverses. This is just a review. Okay, this is just review. So how do we estimate? There are two things that we estimate. We either can estimate tangent lines or we can estimate derivatives. Tangent lines are for like g of negative 1.1. That's not what it asked. It asked for the derivative. So our derivative we do with the whole algebra 1, like y2 minus y1 over x2 minus x1. But we're going to practice this the calculus way. So we're going to say g prime of negative 1 is approximately, now we don't have the value negative 1, but negative 1 would be somewhere in here. So we're going to use these two. You can do g of 0 minus g of negative 2 or g of negative 2. It doesn't matter which one comes first. I'm going to go g of 0 minus g of negative 2. But like I said, you could flip the order. Divided by 0 minus negative 2. Right? That's y2 minus y1 over x2 minus x1. Okay, g of 0 is negative 3 minus g of negative 2 is 2. So negative 3 minus 2 divided by 0 minus negative 2 would turn to positive 2. So you get negative 5 halves. So that's estimate the value of g prime and negative 1. Box it. That's an answer. Based on this value, what conclusion can we reach about g? Now we want to remember, what does g prime tell us? It tells us the slope. It tells us if we're increasing or if we're decreasing. So g prime of negative 1 equals negative 5 halves, which is less than 0. So g is decreasing at x equals negative 1. All right, estimate the value of g double prime. This is a little bit tougher, and we haven't really talked about second derivatives so much, but we're going to kind of learn this one, and it's not too bad. It's just doing it, but with the first derivatives. So basically, the way that, right, f of x would be our original, and if we take the derivative, we get f prime of x, right, which is our first derivative. And if we take the derivative of that, right, like if we do the derivative of that guy, then that gives us f double prime of x, which is our second derivative. So if we were going to estimate g double prime, it's the same process, but instead of using the y2 minus y1 of the original, we're going to do the y2 minus y1 of the derivative. So we're going to basically say that the second derivative would be g prime of 0 minus g prime of negative 2 over 0 minus negative 2. We're kind of doing that same concept, right? So now g prime of 0 would be the 2 here, and g prime of negative 2 would be the 3. So 2 minus 3 over positive 2 would be negative 1/2. So we're going to box that, and I'll use another color just so we don't get everything blending so much. What conclusion can be reached about the graph of g prime? It's the same thing. So because g double prime of negative 1 is equal to negative 1/2, and that's less than 0, that means, so g prime, not g, but g prime is decreasing at x equals negative 1. So what does that mean? It means that the graph is going down and the derivative is going down. So the derivative is going down even faster and faster. So it's kind of like going to be like a decreasing graph that's like decreasing more and more and more, right? The derivative is getting smaller and smaller. So anyways, this is kind of a little bit of a, we're not going to test this. This is just us getting ahead, right, for a future chapter. So if that confused you, it's okay. I know this whole video was very, very weird. Here's my promise to you. On our test, on test 3, you're going to have one multiple choice on this. So you get that multiple choice wrong, you can still get an A on the test. It's not going to be on the free response. It's only going to be one multiple choice for this whole topic.